start recording and let us do this. So today we are going to deal we completed the equation of Bernoulli's principle and all. Like we derived this relation, everything, Reynolds number, streamline flow. We were doing dynamics. So we ended up like we thought. Let us solve some problems regarding that, and I'll be sharing one by one questions to you. You'll have to do within some 4 to 5 minutes, and then I'll be solving the solution for that. Okay. So whatever is the concept, you know that for any point, this equation is always there. You have to always see about this equation that the pressure plus kinetic energy per unit volume plus potential energy per unit volume is always constant if the liquid is following or if the liquid is an ideal fluid. Which kind of fluid it is? Is that clear or not? Okay, so look over here. I think this is visible to you. Or should I make it little bit bigger? So the question is, a piston is pushed with constant speed of V1, 2 meter per second. Okay, first see the question and then I'll decrease the size. Okay. What it is asking that a piston is pushed with a constant speed of V1 is equal to 2 meter per second and A1 is equal to 100 centimeter square, A2 is equal to 20 centimeter square, H is equal to 1.25 meter. Means what it is saying that there is a pipe, okay, and in this there is this piston, okay, and I'm pushing it, this water is coming out. The speed which it is going from this side is V1. The speed with which it is coming outside is V2. If this area of cross section is A1, think, and then there is A2 over here. Then find V2, volume of rate flow, mass flow rate, range R, pressure at point A and B respectively, means pressure at this point and pressure at this point, and then force required to move the piston with constant speed. Do it. ठीक है, बताओ जल्दी से. V2 is easy to find, isn't it? Look over here. I can find this V2 easily or not by applying, since this is the ideal fluid, I can apply between these 2 points the equation of continuity, isn't it? So A1 V1 is equal to A2 V2. A1 is given 100 centimeter square. V1 is given. V1 is given to us or not? It is given 2 meter per second. Why I'm writing the SI units? Because sometimes areas are different, so it's better to write the SI units so that it can be easily cancelled out and all. Okay. So follow this procedure every time. A2 is given 20 centimeter square and V2 I need to find out. So centimeter square got cancelled. 0 0 got cancelled. 2 2 got cancelled. So V2 is nothing but 10 meter per second. Means the water which is coming out, V2 is given as 10 meter per second over here, isn't it? Yes. Now try to understand that this water droplet is falling after some time to this level or not. Yes. So, first we will get into range R, but first we need to find volume rate flow and mass rate flow. So, second point, what is volume rate flow? Simple, dV by dt. Yesterday also I derived that relation. See that volume rate flow was given as A into B, isn't it? dV by dt is similarly. I can put either A1 V1 or A2 V2. You will get the same answers. Okay. So A1 is 100 and 200 centimeter square into 2 meter per second. Okay, so the answer is 200 centimeter square meter per second. You can convert centimeter square into meters and it will give you meter cube per second. Are you able to get me? So centimeter square is 10 to the power of minus 4. So 200 into 10 to the power of minus 4 meter cube per second. Is that clear or not? You can find even mass rate flow. What is my mass rate flow? You know that mass rate flow is given as, I can just write dm by dt is equal to rho AB, either anyone, A1, V1 or A2, V2, whichever you want to write, you can write, isn't it? And if I'm writing mass in SI units, so density of water, this is my water, okay. So if it is a water, then its density is simply 1000 kg per meter cube, isn't it? So you can replace it and you can just find the mass rate flow also, isn't it? So it will come as, I'm directly writing the answer 20 kg per second. Is that clear? Okay. Now, let us move to most important point, and that is the calculation of range R, pressure at point A and B, respectively. So, how to find range R? To find the range R, if I know the velocity, I should know the time of flight of this projectile or not. Without, because this range R is nothing but, see, in horizontal direction there is no acceleration. So range R is nothing but velocity along horizontal, which is v2, into the time of flight. Are you able to get me or not? So the first task which you need to find out is the time of flight. Time of flight is nothing but root under twice h by g, isn't it? Because there is no velocity in the vertical direction, isn't it? So I'm directly writing it. Okay. So root under twice s by g, twice h is given. How much is that? 1.25 meters divided by g is 10. So I can bring it here. This is 125 into, how much is that? This is 5, 1, 5, 25, 5 jar and 25, 4 jar. Yeah. So how much seconds is it? 1 minute, 1 minute. Sorry. I did one mistake. 1 minute. Oh, shit. G is 10, and if I just replace this there is 100, another 100 over here, isn't it? So this is 5 and this is 4, and that is 5 2s are 10, 2 2 got cancelled. So this is 1 by 2 seconds, isn't it? So time of flight is 1 by 2 seconds. So the range is v2 into t. V2 I find out 10 into 1 by 2, which is equal to 5 meters. How much is the range? 5 meters. Are you able to get me? Yes. Now what they are asking, pressure at point A and pressure at point B. So similarly, whenever there is a fluid flowing, you can't apply the normal equation of pressure and find out the answer. You just apply Bernoulli's theorem at these 2 points. Okay. So applying Bernoulli's theorem at these 2 points, simple. What I will get? Pressure at A plus rho, velocity at A, which is v1 square, plus, and if I consider this as only my reference point, so the potential energy will become zero, isn't it? Because both of them are at same height from the ground, isn't it? So let us just write mg rho gh, height of A, that is equal to pressure at B plus half rho v2 square plus rho g h of B. Are you able to get me or not? Is this is going to be my equation or not? Isn't it? Hmm? Now look over here. If I just think of B, then this B is in contact with the air. So if it is in if it is in contact with the air, rho g h of B, then pressure at B is nothing but atmospheric pressure, isn't it? So this rho g h A, rho g h B got cancelled because height of A and height of B are same. Okay. So the equation is P of A is PB, which is 10 to the power of 5 Pascal, plus rho half 1000. V2 is your 10. So 100 minus V1 is, you calculated 2, it is given 2, so 4. So that is 10 to the power of 5 plus, you just solve it, half 1000 into 96. So this answer will actually come as, I'm directly writing you the answer. Okay. This will come as, this is a very big equation, 10 to the power of 5, and they have directly written 48 into 10 to the power of 3 Newton per meter square. Are you able to get me or not? And if we ignore P naught, then if I want to find pressure difference, so PA minus PB is nothing but 48 into 10 to the power of 3 Newton per meter square. Are you able to get me? So this implies that pressure at A is greater than pressure at B, isn't it? Are you able to get me? So if pressure at A is greater than pressure at B, try to understand. So this will provide us some kind of force on the piston. Then only the, if P of A is greater, then that means only one thing, that at that point I need to apply some extra force, isn't it? But the question arises that how you are going to apply that extra force. Are you able to get me or not? Yes. So look over here. If I just see the piston, so this is my piston, isn't it? Which is trying to push that water with constant velocity. Look over here. This is my piston which is trying to push the constant velocity, isn't it? So look over here. I'm applying some force to move with constant velocity, isn't it? Now, if I'm applying the force from this side, since this is the air region, so atmospheric pressure P naught into area A1 will be present, isn't it? And at point A, right now you just calculate that at point A there is a pressure which is 10 to the power of 5 into 48 into 10 to the power of 3. That pressure, which is P of A into area A1, will be present from behind to oppose that motion. So F is what? F is nothing but simple pressure of A into A1 minus P naught into A1. Yeah, so F is nothing but PA, which is 10 P naught plus 48 into 10 to the power of 3 minus P naught directly into A1. So P naught got cancelled. Net force is 48 into 10 to the power of 3. And I have to write A1 in terms of SI units. So 100 centimeter square, centimeter is 10 to the power of minus 4. So two zeros will cancel and it will be minus 2. So it is nothing but F is equal to 480 newtons. This is the force which must be applied to move the piston with a constant velocity. Are you able to get me? Is this clear? Okay, can I move to next question? Yeah. Yeah. Okay, so it's an official announcement for YouTube, guys. If you want to have the PDF of this booklet, please join our Telegram channel, Physics to Physics. Okay, that's called Prachar advertisement. I'm doing like Narendra Modi. Yeah. Now tell me, find the gauge pressure of point B with respect to point A. I have I have told you about gauge pressure also. Na? Mm-hmm. Already done. Gauge pressure, absolute pressure, everything is done. Hmm. So बोल रहा है find the gauge pressure of point B with respect to point A. If you want to see what is gauge pressure, I have done it long back, too much long back. See, absolute pressure here, gauge pressure here also I have done. Gauge pressure is that extra pressure which is apart from the atmospheric pressure, isn't it? So this is absolute pressure minus atmospheric pressure is called as gauge pressure. But here the gauge pressure, actually the gauge pressure is defined for 2 points, isn't it? Here- Yeah, but that is for atmospheric pressure. Here it is asking that find the gauge pressure of B with respect to A. So that means what is the extra pressure at B with respect to A? Means gauge pressure here is defined as PB minus PA. Are you able to get me? Yeah. Hmm. Hmm. How to do it? Simple. First, you have to consider. See that. First, consider a reference line because you will require for your potential calculations, isn't it? Then mark the 2 points. This is A. This is B, isn't it? Now, whatever is this ideal fluid is there, so I can apply at these 2 points or Bernoulli's equation. So P pressure at A plus half rho V at A square plus rho G H at A. If this is my reference line, isn't it? If this is particularly my reference line, then we know that pressure of A, sorry, height of A will be equal to height of B and that will be equal to 0 or not. Yes? So pressure at B plus, yeah, because that is my same reference point, rho G HB. So this is, that is just similar to 0. You just write similar to 0. You just write similar to 0. So P of A minus P of B will appear as half rho V of B square minus V of A square. V of B and V of A is given to you. P of A minus P of B is half rho V2 square minus V1 स्क्वायर. इफ अगर यहाँ का एरिया पता होता है, यहाँ का भी एरिया पता होता तो हमें मालूम होता है V1 और V2 के बीच में रिलेशन भी. ओके, so you look over here, this PA minus PB is greater than 0, isn't it? So what does this mean? That pressure at A is more than pressure at B. Are you able to get me? The sign is gonna change, isn't it? Yeah, so that means one, yeah, so that means one thing that, अच्छा एक बात बताओ, let's suppose if A1 B1, if I write A1 B1 is equal to A2 B2, yes, and A1 is bigger than A2, A1 is bigger than A2, okay. Now look over here, if A1 is bigger than A2, that means what? I can write A1 by A2 V1 is equal to V2 if I want to find V2, isn't it? So look over here. When A2 is less, V2 is, this will be more or not. Means for less cross sectional area, V2 becomes higher, and for bigger cross section, V1 is lesser, isn't it? Yes. Now, if V1 is lesser, you see that. Try to understand. If V1 is less and V2 is more, then only P minus PB is more, isn't it? Positive. So what does that suggest? If you have less pressure, means if you have more pressure, then your velocity is less. More pressure implies uh, if velocity is, yeah, means here pressure is not following the relation force by area. Remember that. Okay. Yeah, force by area is just only for the case of statics, not for the movement. Okay. Yeah. Is that clear? Next question. Try. Once again, you have to find the gauge pressure between AB. Find in both cases P of A minus P of B. PB minus PA. Do it. Achha. So what we can do? We can simply apply equation of continuity, isn't it? So A1 V1 is equal to A2 V2. That means this is also V only, isn't it? So apply your yeah. So you just consider this as a reference line. That is much more easier to understand. Mhm. So it will be PA plus half rho V of A, which is V square, is equal to P of B of rho Vs plus 0, isn't it? So that means this and this also got cancelled, isn't it? So what I'll do here, I can get PV minus PA is equal to rho GH, isn't it? So that means pressure at B is more. Pressure at B is more, not lesser. Correct, correct. Similarly, if I do this equation, this is twice of A, this is only A. So if I apply twice of A into V is equal to A into V dash. So V dash is equal to nothing but twice of V, isn't it? So once again, yeah, it is twice of V and this is my reference line, isn't it? Once again, I'll apply the same equation. This is for second one and this is for third one. P at A plus half rho V square plus rho GH is equal to P of B plus half rho into twice V square, sorry, twice V whole square plus 0. So you solve it and you will get PV minus PA or not. So it will appear as, this one will come as PV minus PA is equal to rho GH plus something like half. No, no, it will be I can just directly write minus 3 by 2 rho V square. Is that clear? It's not plus. Okay, is this done? Can I move to next question? Okay. And let me make it little bit small. Yeah, now you got it. What it is saying? I'm sending some liquid. Sorry. Okay. I'm sending some liquid. So it has some velocity v. Okay. It is going means this liquid is coming up with some kind of velocity v2. Now what it is saying that after coming out it starts to spread. Okay. No, means try to understand. And this is point B. The question is, it is asking when this liquid starts to come up, find the height where this area of cross section of this liquid, okay, this particular area becomes exactly equal to the area A which we have defined earlier. Find the height where this area also once again become equal to A, area A1. Are you able to get me or not? Is that clear? Yeah. Okay. So here what it is given, A1 is equal to thrice A2, means here it is area A1 Here it is area A2, and here it is once again area A1. Area A2 is equal to thrice of A1. So I can get easily my. Okay, A1 is given as thrice of A2. So whatever is there means we can find the relation between V2 and V or not, isn't it? Yes. So let us find this relation first. A1 V1 is equal to A2 V2. A1 is A, V1 is V, A2 is thrice A1, thrice A, and velocity V2. So you look over there. 1 minute. A2, sorry, what I'm writing. A2 is A by 3, isn't it? So V2 is thrice of V. Are you able to get me or not? Means this velocity V2 is thrice of V with which the particles are going. Now, whatever happens, let's suppose if here my velocity is V3, okay. But that velocity, if it becomes similar to area A1, that means that velocity V3 must be also equal to the same velocity of the liquid which is present over here, isn't it? Yes. So first question is find the gauge pressure of point A. Means you have to find how much dip. It is asking about one point itself. Now you have to compare with respect to atmospheric pressure. Are you able to get me or not? So how you will consider? No problem. See that at point B, the V is in contact with air, isn't it? So if it is in contact with air, pressure at B is nothing but atmospheric pressure P naught. So I can apply the particular Bernoulli's principle. This is height is given already. P of A plus half rho V square V of A plus rho G H of A is equal to P of B. Simple, same, whatever is given over here as height. This is my reference point. Okay. So rho G H of B. H of A, this will be 0 because it is present at the same height, isn't it? Okay. Are you able to get me? And that is P of A is equal to half rho V of B. You got to know V of B is 3V. So half rho 9V square plus rho GHB. HB is given height H. So rho GH. Is that clear? Plus P of B. Okay. So P of A is equal to P of B, which is atmospheric pressure, plus how much we are going to get? Let me check. I'll directly write it. So half rho is given to you, that is 10 to the power of 3, 9V square. 9 velocity is also already given 6 meter per second. So 6 are 36. So 9 into 36, isn't it? Plus rho GH once again 10 to the power of 3 is my density. Gravity is 10 and height is how much? Height is also given 10 meters. So if you solve it, P of A will come as P naught plus this appears to be 2.44 into 10 to the power of 5. Okay. So the Gauss. No need, no need. It is asking gauge pressure at point A. So gauge pressure at point A means whatever the pressure is extra apart from atmospheric pressure is my gauge pressure, isn't it? Hmm. Okay. Is that clear? Now find, it is asking find the height h1 at which area of cross section again becomes a1, isn't it? So find height h1 now. That is your task to find. You have to do it right now. Okay. Hmm. Okay, do it fast. Once again, you just apply now Bernoulli's equation. See, if I apply Bernoulli's principle, okay. No, no, just compare B and C. Yeah, correct, correct. So P of B plus half rho velocity at B square plus rho g h of B is equal to P of C. So half rho V of C square plus rho g h of C. P of B now, both are in air. So P of B is equal to P of C, which is equal to atmospheric pressure P at E. So they will cancel, isn't it? So what I will get? Half rho VB square, VB is thrice of V. So half rho into Y 9V square, and that is equal to V of C. We know that it is similar to the velocity V because it needs to be area to be same, isn't it? So half rho into V square, and 1 minute, sorry. I can take height of B as a reference point, means I can even measure from here also. So H of B becomes 0. Yeah, isn't? So H of B becomes 0 also if height of B means लिख लेना if height of point B is taken as reference point. Okay, so this becomes plus rho g height of C. So that is simple. So 8 by 2 rho v square, rho cancel, 2 4 ja 8. So h of C is equal to 4, v is given 36. V square will be 36, g is 10. So this is your answer. This will be equal to 14.4 meters. Is that clear? Okay. Can I move to next question? Okay. Do it. This is called a siphon tube, which we utilize it. It is saying that I have some liquid filled up till over here, and I have a siphon tube, and I am just applying some pressure. Okay, so it is asking, let's suppose the height inside the liquid is H2, the height from there to there is H1, and height above the liquid surface is H3. Then find pressure at A, pressure at B, and pressure at C, and find the condition for which the liquid flow will take place. Is that clear? Hmm. This is A, this is B, marking it once again, and this is point C. Okay. Okay, solve 1 minute. I'll just bring my charger. Do it fast. You have last 2 minutes. Bana? Okay. Should I help you out or okay? Got the equation for the first one. So what is velocity of A, velocity of B, and velocity of C? First thing you have to identify that only. Velocity, if yeah, very good. So if area of cross section is same, velocity is also same. Yeah. So that means V of A is equal to V of B is equal to V of C. Consider it to be V. Are you able to get me? Yeah. So I can directly apply between any 2 points the equation. But the easiest task to apply, listen. The easiest task to apply will be between A and C or B and C. Why? Because at C I know that it is in contact. Yeah, it is in contact with the air. So it has awesome. Now your concepts are really great. Who said your physics was weak? Huh? So it has equal to atmospheric pressure. These are the questions which are of J advanced and you can handle it in very awesome way. Okay. So now look over here. So pressure at A plus half. Okay. Now the question arises: what is your reference point? Isn't it? That's the biggest question. So you want to make C as your reference point, means this line as your reference point, isn't it? Okay. So if If this is your reference point, then point A is located at height h1. So half rho v square plus rho g h1 is equal to P naught atmospheric pressure at C. I'll write PC plus half rho velocity at C square plus 0 because height is 0. So P of A, this and this are same, cancel out. So P of A is equal to P naught minus rho G H1. That is my pressure at A, isn't it? Similarly, I can apply for pressure at B. So half rho, I'm not writing half rho because that will be cancelled out, isn't it? So rho G, height is from H1 plus H2 plus H3. Yeah, simple. PC plus 0. PC is P naught plus 0. So P of B is equal to, I'll write it also. So P naught minus rho G H1 plus H2 plus H3. So you got it now. Condition of PA, PB and PC. Next thing, condition for which the flow will take place. Tell me, what should be the condition? Yeah. What is the necessary condition that the flow will take place? See, if you look over here, if I consider this, from here the atmospheric pressure P naught is applying pressure, isn't it? Water will definitely go inside this liquid, this particular column. It starts to rise up, it starts to go here and there. Water will definitely come out. If it crosses this barrier, then water flow will be maintained or not. So the conditions would be same to move to flow. For flow, simple. Pressure at B should be greater than or equal to, should be greater than always 0, isn't it? It should never be negative. So even if it is equal to 0, this will be the higher pressure and it will make the particle to flow like that way. Yeah. Yeah, so it should be always greater than or equal to 0. So if I write the equation, then it becomes simple. Like you got the relation that P naught minus PB is given. You got it already. P naught minus rho G plus H2 plus H3 must be greater than or equal to 0. So you got the relation that height must be in some range, that H1 plus H2 plus H3 must be uh, less than, since it is negative, so it will be less than or equal to P naught by rho G, then only the water will be flowing. Are you able to get me or not? Okay, is that clear? Okay, can you move to next question? Okay, to this wall of area A is made at one wall of a vessel of area A. Okay, so there is an hole which is made and the liquid starts to flow from there. Okay. Hmm. Find the speed at which the liquid comes out of hole, and this is called as speed of efflux. क्या बोलते हैं इसे अपन? Yeah. बताओ. Mhm. Uh-huh. Hmm. Bana? P at A. Yeah, you can consider P naught. Yeah, it will be P naught. Think. You have too much to think. Mm-hmm. चलो देखो एक बात देखो. See, there is some way to solve this kind of problems. First thing, as this water will come out, the water from the top will also come down, isn't it? Yes, the water from top will also come down. Let's suppose we are not aware with what velocity it is coming down because this area is given capital A. Okay, the area of top surface is given capital A. The area of a small surface is given a small a. Okay, so here the velocity, let us consider that the velocity with which the water is coming down be some kind of V dash. What I call it as V dash. So applying equation of continuity, simply you will get the equation now that area capital A into V dash is equal to area small a into a small v. So you got the V dash relation. V dash is A V by capital A. Now let us consider these 2 points A sorry P and this one as Q. Can I apply simply Bernoulli's equation between P and Q? Okay, so Bernoulli's equation at P and Q. If I apply that, what will happen? Simple. P of Q, sorry, pressure at P, which is atmospheric pressure. I'll write that half rho velocity at P square plus. If this is my reference level, okay, this green one is my reference level. Okay, you can consider the bottom one also, but that's of no use actually, isn't it? Basically these heights are different, h1 and h2. So it will give us a, it will left out, means it will left out with two variables once again. So rho g, it will be rho g, 1 minute, h1 means that height of point P from the reference level is h1, isn't it? Atmospheric pressure at Q is PQ plus half rho velocity at q square plus 0. Now you know that if this is point P, pressure at point P is equal to pressure at point Q, which is equal to atmospheric pressure, isn't it? So this one also got cancelled, and we know half rho velocity of P is given to us. Velocity of P is v dash, and I know that v dash relation is a square v square divided by capital A whole square, isn't it? Plus rho g h1 is equal to half rho. Velocity at q is v square, isn't it? So you just bring it over here, and what we are going to get is, let us take half rho v square common, and that is uh, that will become. It's better to send it that side. 1 minute, sorry. This means rho g h1 is equal to half rho v square common 1 minus a square by capital A square. Rho cancel. So v is nothing but root under the velocity with which water is coming out is called as velocity of efflux, that is equal to twice g h1 divided by 1 minus a square by capital A square. Is that clear or not? This is my velocity of efflux. Is that clear? Are you able to get me? Yeah. So now there is one conclusion I'll try to see. As this hole is very very small, means this A is too much small than capital A, isn't it? Velocity. Yeah. So this velocity is nothing but just root under twice g h1. How much is that? Twice g h1. Is that clear? So that you got. Second question is range of liquid over ground. Okay. So range of liquid over ground. So yeah, that is v into time. So range is velocity into time. Velocity you got root under twice g h1, isn't it? Time is what? Time of flight will be root under twice h2 by g. Yeah, g got cancelled, and we got range as 2 outside root under h1 h2. This you need to remember. Okay. This is asked directly in NIT exams. Range is equal to 2 root under h1 h2. Okay. Is that clear? So range of liquid is over value of h1 and h2 for maximum range. Now you tell me what is that? What will be that relation? What can be the so what can be this h1 or h2 relation such that the range is maximum? Is there equality will bring us maximum range? Oh, today I have got lot of fever, Baba. Okay, so let us just take if h1 is there, so can I write h2 as nothing but capital H minus h1? Yeah. So r is what? Nothing but 2 root under h1 capital H minus h1. I want my range to be maximum, and that range is variable as this orifice level is variable, isn't it? Means if it is asking find the value of h1 and h2, that means what it is asking? This particular whole level they are changing here and there, isn't it? So find the maximum or minimum of any quantity. just divide it with respect to the variable quantity. I am making the h1 to be variable. So dr by dh1 will provide us the answer for that, isn't it? So that will be what? 2 by the square root. This is whole bracket to the power of what will be that? Yeah, so it will be 2 divided by 2, isn't it? And root under h1, h capital H minus h1, h minus h1, and that is okay. I'm just removing this root. That will be absurd. Yeah, so h1 capital H minus h1 1 by 2 minus 1 because its power is 1 by 2. It is. Arey Baba, its power is what? 1 by 2. If I take the differentiation, then 1 by 2 will come. Okay. Now we will have to apply the chain rule. So this is h1 into h minus h1 square. So we will get the relation as h1 minus twice, sorry, h1 is cutted down. So capital H minus twice of h. Is that clear or not? So the relation is dr by dh1, 1 by 2 minus 1 is minus 1, so 1 by, it will come as h minus twice of h1 divided by h1 h minus h1 to the power of 1 by 2. Is that clear? And that I need to be put it 0 so that to find maximum or minimum. Denominator cannot be equal to 0, but the numerator can be equal to 0. So h must be equal to, that means h1, and that implies if I want maximum range or minimum range, for max range height of h1 must be capital H by 2, that must be equal to of h2. Is that okay? Is that okay? Fourth question. Thrust force exerted by liquid on the vessel. Initially, do it. Tell me, what will be the thrust force exerted by liquid on vessel? What is the meaning of thrust? That I made you understand. Thrust means the force applied by the liquid on the container, isn't it? Yes. So, what is thrust? If you look over here, whatever the liquid will be applying the force, that force is making the liquid to come out, isn't it? That is only that force. This is that only force. The net resultant of that force is only making the liquid to come out. Now, so simple. Force is what? What is thrust force over here? Remember, whenever there is a variable mass, which kind of mass? Liquid is coming out and it is getting emptied inside the container. Whenever there is a variable mass, I'm writing this concept for variable mass. always my thrust force, like it is always used in rocket concept also, that the thrust force is exactly equal to the velocity into rate of change of mass with respect to time. Are you able to get me or not? So velocity is given dm by dt is rho, area is given a, and velocity is v. So the equation is simple: thrust force is rho a v square. Are you able to get me or not? Is that clear? So you can apply simple. Always you apply that. Okay. Is that clear? Then only it will be possible. Take. Now, second point is you have the relation of v over here. You have got v root under twice g 1 divided by root under 1 by, like if a is very small, v is root under twice g h. So it becomes equal to, for very small orifice, thrust force is simply twice rho. So it is twice rho a g h. That is my thrust force. Okay. Okay. Can I move ahead? Now, remember that this is the thrust force when the body is moving with constant velocity. Okay. Like, I'll tell you one thing. Let's suppose mass starts to vary. Okay. Actually, the net force is equation is always d by dt of mass into velocity. Okay. So, the Newton's second law says that mass is constant and if velocity varies, then it is given as mass into acceleration. That is the force provided to the body to move with the acceleration. But there are forces which are provided by the body itself to move with constant velocity, and that force is called as thrust force. To move with a constant velocity, the body applies the force by itself on the outer region or opposite to the movement direction, and it is given as v, constant velocity v, variable mass with respect to time, dm by dt. Important point is, if both are varying, velocity and masses both are varying, then the net force equation is provided by m dv by dt, means acceleration also, plus v dm by dt. This is the whole equation. That is why this is my Newton's full equation, but this was not prescribed by Newton's. Okay. Is that clear? Okay. Can I move ahead? Okay. Do the next question. Yesterday I told you, no, I'll puncture your head. When I tell it, I do it. So once again, it is saying that a small hole of area A is made at one wall of the vessel of area A. Okay. Find the height of liquid. So is made at one wall of area of vessel A. So find the height of liquid surface at time t. If initial height is h, find the time required to completely empty the vessel. Means this hole is made over here. Okay. Yeah. So find the height with respect to time, means you know that the water level will start decreasing and all, like this vessel will be seen as, I mean, we will see that the liquid level has dropped. So this is the surface will be now. So there is this height change. This was my original height. Now the height from the ground is different. Yeah, height relation. Yeah, you have to find this relation of height with respect to time. Let's suppose this is h. So you have to find h with respect to time. Okay. Hmm. Hmm. Okay, now look over here. See this. Let's suppose this liquid water is coming out with some kind of velocity, isn't it? Same velocity it will be always maintaining. So from top also it will have some velocity component in the downward direction or not. Let's suppose if this is v, this is v dash. अरे कुछ तो बोलो हाँ है ना. Yes. If it is area A, it's given this is area small a, this is area capital A, this is area small a. I can apply equation of continuity that A into V dash is equal to A into V, isn't it? So this implies you got the relation for V. V is nothing but sorry V dash A V by capital A. Yes. Now if try to understand, try to mm, what to say, what to say. What to say? What to say? 1 minute. Of height of liquid. अच्छा एक बात बताओ अगर if what it is saying that find the height with respect to time t, isn't it? So अगर मानते हैं कि लिक्विड सरफेस की जो हाइट है h in time t, then can I just write this velocity relation? Yes, you only tell me. You see, if height h is there, so when all the liquid will come out of it, the velocity will be what? Just nothing but root under 2gh. Yes. So velocity of efflux, like if I just like initial case, see that here it was like let's suppose if this is my surface over here. So how much level is there? H1 is the level or not? So velocity of efflux was what? Root under 2gh1, isn't it? The height of the liquid above it. So velocity of efflux or which is v, if orifice is very very small, it is just nothing but root under twice or into height of the liquid which is above it. Are you able to get me or not? And once again here a is very very small, so that is why I'm just writing it as. Is that clear? Are you able to get me? So you got your velocity equation. You just need to apply it over here that v dash is equal to a root under twice gh by capital area A. Are you able to get me? Now, if you look over here, what is V dash? V dash is nothing but the change in height with respect to time, isn't it? Yes, that is only my V dash now. ds by dt. So ds by dt is equal to A by capital A root under 2gh. Is that clear? So applying, see, previously we defined the efflux velocity. We didn't define what is this h1 with respect to time, isn't it? Now, in this question, we are defining h1 with respect to time also. So it will be dh by root under twice gh, which is equal to a by capital A into dt. If I do the integration, I'll definitely get the answers, isn't it? So at t is equal to 0, the whole liquid was at height h. At t is equal to any time t, the whole liquid is at a small height, small h. So if I do the integration, what I'll get it? Look over there. 1 by root 2g common 1 by root h. So h to the power of minus 1 by 2 dh is equal to a by a, and that is into t, isn't it? And this is capital H to small h. H by to the power of minus integration, that is your task to do. I'm just writing the direct form. Is that clear? So it comes usually as root h only. If it is 1 by root h dh, then it is root h. Remember that. Remember this integration trick. Integration 1 by root x dx is always root x. Are you able to get me or not? So if I just write it, so 1 by root 2g I'm sending that side, so it will be root under small h minus root under small h minus root under capital H, and that is equal to root under twice g capital A by small a by capital A into time. Is that clear or not? Are you able to get me? Now one factor is there. Just try to understand that this height is decreasing in nature. Which kind of nature? Decreasing. So it's better to include, like let's suppose I can include a negative sign on right hand side or left hand side. But if I'm saying the velocity factor with respect to displacement, so this is basically negative in nature. कैसा है nature? Negative. So I can just send negative this side, isn't it? So you got your root h relation. H is equal to nothing but root under capital H plus capital A, small a by capital A into root under twice g into time period t to the power square. That's your relation of height. Is that clear or not? It should not be plus, it should be minus. Sorry. Is that clear? So the question is, if I want to completely end up the particular vessel, so that means this height must be equal to 0 for empty vessel. So T is equal to nothing but root under H by 2g. I'll write the equation. T is equal to simply capital A by small a root under h by plus c. That's the time taken. Okay. So many people ask you that can you just draw the diagram of variation of this height? Okay. They ask you that draw this diagram of variation of height of this water level with respect to time. So look over there. If you see that it is a parabolic equation. Which kind of equation it is? It is always decreasing or not? Yes, so the graph is, if this is a small h and this is time t, so the graph is basically a parabola and this value becomes 0 after time t. Okay, yeah, so and here the slope is provided by, slope is nothing but this will be 0, it is minus of a by capital A root under uh, twice g root under twice g. What will be the slope? Y is equal to mx into c. यही होता है ना mx plus c. So if I write the slope, m is what? Y by x. So I'll have to multiply with height over there. So y root under twice g h. So this is my slope of the graph, which is dh by dt. We call it as, this is nothing but dh by complete. Is that clear? Totally done? Okay, moving to next question. Tell me. Yeah, it's not an easy tab problem. It's a tab problem. Do the tab problem then. Tomorrow, do we have class? Okay. Same time, 9:15. Early in the in sense at what time? 6 p.m. Okay then, 6 p.m. tomorrow. Do it fast. Tell me what will be the answer. 2 minutes are over. अच्छा, one point, simple सी बात, velocity of efflux. First thing is that it's easier to find radius if you know the velocity of efflux. What is velocity of efflux? Root over 2g capital H, isn't it? We're asking radius of cross section at point B is capital R. Okay, radius of cross section is given. Find the speed and radius at point C at given instant, isn't it? ये पूछ रहा है ना बस. तो सिंपल, अगर मान लो रेडियस पता है तो हम बी और सी पे वो लगा देंगे, बर्नौलीज इक्वेशन लगा देंगे. It will. Why? You tell me one thing. This is the velocity only that is going to provide us the conclusion, isn't it? Huh. Yeah. Applying. और यहाँ पे ऐसा मत कर देना, यहाँ पे यहाँ से लेके यहाँ तक वी स्क्वायर इज इक्वल टू यू स्क्वायर प्लस टू जी एच मत लगा देना भैया, ये फ्लूइड फ्लो है, ओके. So many people will do what? They will apply that v square plus u square is equal to 2gh and they will get the answer e. So, but you will get the same answer, but it's not of good use. Okay. So applying Bernoulli's equation between B and C. So B पे प्रेशर है P नॉट प्लस हाफ रो V ऑफ B स्क्वायर, और इसी को मैंने मान लिया C को मान लिया मैंने रेफरेंस पॉइंट. ओके. सो this will be rho g h is equal to P naught plus half rho V of C square plus 0. Rho also got cancelled. VB is root under 2GH. So 2 cancel and this will be just GH. So this will be V of B is given to you. This is just uh, G capital H, G into capital H plus G into a small h is equal to half V of C square, isn't it? So you got velocity at point C, it is root under C twice G capital H plus small h. Is that clear? Okay. Now what it is asking, as I know radius, so simple, A1 V1 is equal to A2 V2. A1 is pi capital R square. B is known to us root under twice Z capital H. A2 I need to find. A2 means pi R dash square into V2 you have got right now root under twice Z capital H plus a small h, isn't it? So pi got cancelled. R square into me है, into me है. अच्छा इसको ऐसे करो, R dash square by capital R square is equal to root that will be root under twice z cancel h by capital H plus the small h, isn't it? यही आएगा ना. So if I just send this over here, so R dash will be equal to R. इनके ऊपर एक्स्ट्रा रूट पहले से है ना. Square is already there ना. If I just 1 minute, ठीक है कोई दिक्कत नहीं. That will be h plus capital H plus small h to the power of 1 by 4. Okay, is that clear? So this is your radius. Okay, can we move ahead? Next, wait. Yeah, there are two different fluids. Okay, take into consideration there are two different fluids lying on top of each other. One is of density rho, another is of density 2 rho. Then find the speed of efflux. Speed of efflux is always independent of density. You will get to know. You see that. Solve it. Think. It's not easy. Think once again. Hmm. From here where I am residing in Kana Santivalam, it's the world's biggest meditation center. Okay, so here from all over the world, there are many meditation practitioner and spiritual gurus now. All are coming from 14th of March to 17th of March. Yeah, Sadhguru is also coming. Sadhguru, then many guys are coming. Ramdev Baba and all. Okay, and even most important thing, apart from these guys who are good guys according to the world's views, but I feel the most important person who is going to come over here is that singer uh, Mahadevan is there, na Shankar Mahadevan. So he is going to come and perform over here. So I'm waiting for his concert. Yeah. चलो आगे बढ़े. देखो, समझो इसमें थोड़ा सा लोचा है. लोचा ये है कि प्रेशर डिफरेंसेस बहुत ही अच्छे अच्छे हैं, बट यहाँ पे बर्नौलीज इक्वेशन अलग अलग लगता है. But everything is perfect, but Bernoulli's principle is totally different. Here pressure is P naught, isn't it? Here pressure is totally different. I call it as, let's suppose this point is C, so I call it as pressure at C. Okay. Here the pressure is totally different. I call it as pressure at D. Okay. So you have to keep in mind, although they are lying on top of each other, so whatever the water flow will be there, water flow. No. We can't say that. Okay, we'll say later on. Yeah, it is same only, but later. So it is P naught only, but let us say later on. Okay. So now the point is, whatever is the velocity, if it is V2, so here also it will be same. But the pressure will start varying for the two different liquids, isn't it? So let's suppose this is CD and this is point B. Okay. So I can apply Bernoulli's first. Bernoulli's. Okay. Equation between B and C. So pressure at P is P naught plus half rho V square, isn't it? And once again that thing is given, area and all everything. So our velocity of efflux will be nothing but how much will be that? We'll talk about that. No, no. It is asking. It is asking velocity of efflux. So V will be equal to V dash will be equal to means V2. Okay, why I have written V2? Okay, let us call V2. V2 will be equal to A into V divided by capital A. Are you able to get me or not? Is that clear? So half rho V square plus, if this is my reference level, this is only my reference level. So no need to think apart from that. Okay, so this is 0 is equal to pressure at C, which we need to find out. We do not, how come it is P naught? So that is uh, half of. After that, if I want to find over here the V2, the kinetic energy equation will be half of twice rho. into V2 square plus rho g h, isn't it? So you will get the equation as P of C is equal to P naught. What will be the equation? Uh-huh. Mm-hmm. PC will be equal to. Acha, 1 minute. Let us you just rho gh. Okay. If I just solve it, it will be P naught plus half rho V square minus. This will be minus. So minus, not plus this time. It will be minus half rho V square minus rho gh. That is my pressure at point C, isn't it? Similarly, I can apply Bernoulli's equation between C and D. I can apply now. इन दोनों के बीच में Bernoulli's equation apply करो. Remember that there are processes how to solve these kind of questions. Okay, so apply the Bernoulli's equation between C and D. And between C and D, if I apply, it is what? P naught plus pressure at C is pressure at C is PC plus half of twice rho V square V2 square, and plus, if this is my reference level for P of C, okay, so this is 0. Similarly, half pressure at D is P naught plus half rho V2 square plus rho GH, isn't it? Is that clear? So the PC will be equal to, you have the relation, half, this will go towards this side, P naught minus, once again, half rho V2 square plus rho GH. Are you able to get me? So look over here. Oh shit. Oh shit. Oh shit. What will be the relation? I it is getting a minute. Equating will not give you the relation. Equating will. 1 minute. 1 minute. Let me just write this equation. PC plus half 2 rho V2 square P naught plus half rho. Minute. Uh, Bernoulli's equation. PC half rho twice rho V2 square. Oh shit. Look over here. How come it will be twice rho? Try to think. When I'm considering this liquid, so I'm just taking this liquid into the consideration or not? Hey, 1 minute, 1 minute, 1 minute. I think here also there is a mistake. 1 minute. Oh shit. Let me do it once again. Okay, now look over here. See, when applying Bernoulli's equation between B and C, okay, no need to think, man. Between B and C, the liquid is same, not 2 rho. So between B, it is P naught plus half into 2 rho V square plus 0, and PC plus half into 2 rho V2 square plus rho GH. यही होगा ना? Are you able to get me? H is similar to a small h because I usually use a small h. Okay. So this is twice rho only. So PC is P naught minus rho v square. This is the whole equation. Basically, if you write PC is equal to uh, half rho, uh, sorry, P naught plus P naught plus, yeah, half of cancel, so rho v square minus v2 square, okay, minus rho gh. This is your formula. Because it is of same liquid, no? Similarly, if I consider C and D, C is applied at same liquid itself, okay? Just before that, it is the same liquid rho, okay? So between C on also, once again, it will be P of C plus half of rho into V2 square. Got it or not? Is equal to plus 0 because reference point is over there, same. PC. PD is, once again, PD pressure is P naught plus half rho V2 square plus rho GH, isn't it? Is that clear? So once again, this half rho V2 got cancelled and PC is equal to P naught plus rho GH, isn't it? So if you yeah, you just equate these two equations, so you'll get it that P naught plus rho V square minus V2 square minus rho GH is equal to P naught plus rho GH. P naught got cancelled. So V square minus V2 square is equal to twice rho. Rho will also get cancelled now. So twice GH. Are you able to get me or not? Is that clear? What? P2 can be written as AB by A. We can put like that. 1 minute, let me just. Yeah, so I got my relation of V2, sorry, V minus V2 square is equal to 2GH, isn't it? हाँ V square. अब एक बात बताओ, ये जो V2 है, try to understand what is V2. V2, what is V2? Can you just relate V2? AB by A. But apart from AB, you look over there. From here to here, V2 is constant or not? So the liquid, no, means if you try to understand, if you just see that the liquid is coming from here to there, isn't it? So if the liquid is coming, if the liquid is arriving from here to there, it is traveling distance h with a constant velocity v2, isn't it? So what can be the velocity v2? Look over there. Is there any term not given over here? Uh-huh. 1 minute. P naught plus this is 1 minute. Why there is a 1 minute? Okay, let me. Okay, so I can put a V2 square. V2 is where I'm. 1 minute. 1 minute. Let me just